Okay folks, unfortunately I'm not able to be in class today. Got a soccer game, wish us luck. Anywho, I thought I'd put together a quick video about today's lesson. So today what we're going to be doing is using the quadratic formula to solve application problems. If you want to get the learning goal down, I strongly encourage you to do so. So I'll leave this up there for another, we'll go 90 seconds. In lieu of saving time on the video, I'm not going to actually leave it playing for 90 seconds. So if someone doesn't mind pausing the video and letting everybody get that down, it'd be a huge favor. Okay, moving on. Let's get everybody warmed up. So what we're going to do is we're going to use the quadratic formula, which we learned on Friday, to determine the roots of each example here. So what I'd like everyone to do is, using the equation in the top right corner, that negative b plus minus the square root of b squared minus 4ac divided by 2a, use that to find the roots of each example. The one on the left, the numbers are a little bit nicer, so it's a little bit easier, and the one on the right, we got some negatives and some decimals in there, so it makes the algebra a little bit trickier, but nothing you guys can't handle. Again, so I'll give you guys probably about 7 minutes to work through this. Once everybody is close to done, or most people are done, we'll look to take up the answers. So again, if you want to pause the video for a couple of minutes, let everyone work on the warm-up, and then we'll take up the answers in a little bit. Alright, so hopefully everyone had sufficient time. Just looking to take up the first example. There's our equation, subbing in all the appropriate numbers. So remember, the number attached to the middle x term, that's your b. The first constant is your a, and the last number is c. So you can see there it's going to be minus 14 plus minus the square root of 14 squared minus 4 times 3 times 10. And then we'll simplify underneath the square root first. We get 196 minus 120, and that simplifies down to negative 14 plus or minus the square root of 76 divided by 6. And from there we can determine that our two roots are x equals negative 3.78 and negative 0.88. Into the second example, same process. So there's our base equation, subbing in all the key values. Simplify underneath the bracket. Okay, notice how it was negative 4 times negative 1.3 times positive 4.7, so it was a negative negative, which ultimately leads to a positive. That's why it's 0.25 plus 24.44. So again, last we were looking at two scenarios. Remember, one for the plus the square root of 24.69, and one for when we want to go minus the square root of 24.69. That's why that plus minus sign is there. So in this case we get our roots of negative 2.1 and 1.7. Approximately. There was a few other decimal places, but I just rounded to 1 in this case. Again, leave this up for another minute just to allow people to copy it down if they didn't get the correct answers or make any revisions. Okay, and moving forward, let's actually look at an example problem. This is an application problem that we can use the quadratic formula to help solve. So again, I'm going to give everybody a minute or two, probably more like 3 or 4, to actually write the question down, and then we'll go from there. So again, if you want to pause the video, allow everyone to write it down, and then we'll proceed. Alright, so hopefully everybody has the question written down. A few key things you want to highlight from the question. It's always really important to highlight the key information in the question. The two key things in this one that I would highlight are your equation, the part that says b equals negative 0.1492x squared plus 1.8058x plus 9. That's the equation we're going to be using here. And the other key piece of information is knowing that x is the number of years since 1988. That's really important to know that it's since 1988. Okay? So what we're going to do is we're going to look at question A. Use the model to predict NASA's budget in 2001. So again, one of the things that I was working on with you guys was breaking down a word problem. Okay, we break it up into 3 sections. The first one is 1. What is the question asking? 2. Well, what does that mean in the context of the quadratic relation? And 3. A plan or tool. Like, how are we actually going to go solving this? Well, in this case, what does it want? What's the question asking us? Well, it wants us to predict NASA's budget in 2001. So that's what we want. We want budget in 2001. What does that mean within the context? Well, really what we're trying to do is we're trying to find B when X is 13. Well, Mr. Reitzel, where did 13 come from? That's a great question, Sarah. 13 because it's 13 years since 1988. Yeah, so that's why it was really important that we highlighted it, the number of years since 1988. So again, how are we actually going to find B when X is 13? Well, we're just going to sub in X equals 13 into our equation and solve for B. So let's go ahead and do that. I have my base equation there. I'm going to sub in 13 for all of my X values. Okay? So I subbed in 13 for X here and 13 for X here. Remember to follow BEDMAS, so you want to simplify your exponents first. So remember you have to go 13 times 13 first before you multiply it to the 0.1492. And once you do the next step, those are the numbers you get. And we can finally simplify to 7.27. So you know that the NASA budget in 2001 was approximately $7.27 billion. Again, we'll leave the video up there for another couple of seconds, maybe another minute, just to let everybody get everything down and ask neighbors questions if you're unsure about where any of the numbers came from. So if we could pause the video. Okay, moving on. Let's do part B. So part B, when does the model indicate that NASA's budget was about $12 billion? Again, we're going to break this down into want, mean, and plan. So again, what does it want? It wants to know when was the budget $12 billion? Okay, what does this mean in terms of our quadratic relation? We want to find X when B is 12. Right, so we're going to sub B equals 12 into the equation, and we're going to solve for X. It's kind of like the one we did in part A, except instead of subbing X in and solving for B, here we're going to sub B in and solve for X. Similar, this one's a little bit trickier, because we're going to use the quadratic formula to actually solve for X. So there's our equation. We're going to sub in B equals 12. Let's let everyone get that down. Before we can actually use the quadratic formula, we have to have everything set equal to 0. So what I have to do is I have to take this B equals 12 and move it over to the other side. But when I move it over, it goes from positive 12 to negative 12. And I can simplify that, and here I have the equation I'm going to use to sub in to my quadratic formula. And just to help people out, the first number connected to the x squared is my a value, the second number is my b value, and the third number, that negative 3, is my c value. Again, maybe give a minute or two just to let everyone get caught up. Alright, hopefully everyone's caught up now. If not, just pause the video for another minute and let everyone get everything down. Let's move forward and let's actually solve this. So we're going to use the quadratic formula to solve for x. I have my quadratic formula there. I'm going to sub in all my values. So I'm going to sub in 1.8058 for B, negative 0.1492 for A, and negative 3 for C. Once I do all my fancy algebra, it's going to simplify to this. And we can simplify under the brackets a little bit further. And this is sort of the equation that we're going to work with. But again, notice how we have this plus minus. This means that we're going to be looking for two answers. One scenario when we add the square root of 1.4705, and one scenario when we subtract the square root of 1.4705. Looks like I calculate both of them at the same time here. Okay, but when you do all your algebra, you should end up with x equals 1.99 and x equals 10.12. Okay, am I done though? Well, not quite, because the question asks, when does the model indicate that NASA's budget was about 12 billion? Now this x is the number of years since 1988. So if you look at the first scenario, x equals 1.99. In this case, x is around 2 years since 1988, which would actually put us at the year 1990. And the second one, we're looking at about 10 years since 1998. That would put us at approximately 1998. Okay, and that would be your answer for the second part. Okay, again, give everybody a minute or two to get the whole thing written down. Ask the neighbors if you have any questions. Alright, moving forward. Let's answer the last part. Part C. What year was the budget maximum? What year was the budget maximum? Okay, so again, let's break this question down. What do we want? We want maximum budget. Okay, what does that mean within the context of a parabola or a quadratic relation? Maximum equals vertex. Okay, so we're going to be looking for the vertex in this case. Well, how do we find the vertex? Well, we don't quite have the zeros in this case. We didn't find those. But what we did find in the previous question was we found the roots. Okay? Those aren't going to be your x-intercepts, but those are going to be 2 points on our parabola that are across from each other. They're going to be symmetrical. So if we take the midpoint of those two roots from the previous section, that's going to give us our axis of symmetry, which is, in this case, what we want. Okay, it's not actually asking us to find the maximum budget, which would be the b value. We just want to find the x value when that actually takes place. So all we have to do is find the axis of symmetry. Again, in order to do that, we're going to use the roots we found in the previous question. Okay? And we find the midpoint of those two roots, add them together, divide by 2, and you get that x is 6.055. But again, is this our final answer? Anybody? Anybody? No? Okay, I'll answer this one. It's okay, I got it. No, we're not quite done yet, because x is the number of years since 1988. So in order to find the actual year, we have to add 6 to 1988, and it puts us in the year 1994. So you can say, therefore, the maximum budget occurred in 1994. And that is it for this example. Hopefully it gives you enough tools and preps you enough to attempt today's homework questions. And again, leave this up for another minute or two if anybody needs to get anything else copied down. Okay, hopefully everybody has everything down. This is the homework. Do questions 12, 14, and 15 on page 404. And if anybody wants to attempt number 19, it's a very challenging question. You actually have to set up your quadratic relation, which isn't something that's not something we've gone over. But if you want to take a swing at it, give it a shot, or if you want to look to take it up the next day, just come in early and